Welcome back, my dear students. How was the quiz? Pretty easy, isn't it? Straightforward. Everything that you learned, everything that you had a hands-on practice, pretty much that's what the quiz was. Okay, good. Well, you ready for the next sub-lesson? So in this sub-lesson, we're going to talk about scale of the coordinate axis. Okay, now what do I mean by the scale of coordinate axis? Let's go back to the world map that we had at the beginning of the lesson. Okay, let Mr. Mac put back up here. Now, did you notice that when I put the map, I scaled it? Look at that, how I scaled it. I put 5, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60 for the x-axis, and for y-axis 5, 0, 5, 10, 15. See that? The reason why I did that is, now look at in between the 30 and 35. If I do, let's take a marker here. Let's say if I put a straight line right there, straight up here, and 30 and 35. See how many countries fall in between that. If I have this one, let's say 1, 2, 3, 4, 5, 6, 7, 7 and 8. 7 and 8, but if I say 7 or 8, there's no way for me to pinpoint, let's say for example, Libya. Say Libya fall right in the middle. Alright? So let's say if Mr. Mac now says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then right here 1, 2, 3, 4, 5, 6, 7, 8, and I want to locate Libya. Alright, now look at that. If I were to say 6, alright, let's say if I say 6 and 4, if I use 6 and 4, see that it fell somewhere else. If I say let's say 7 and 4, also falling somewhere else. See that? So now I need something a finer scale in between these 2 points. Alright, from 30 and 35. That's why I put 30 and 35. That's why I increase the scale from 6 and 7. I put 30 and 35. Now I can have 31, 32, 33, 34, 35. So now look at that. If I say 33, and then if I scale this one, let's say 15, 16, 17, 18, 19. And let's say if I say 18, alright? Look at that, 18. Right there, hits Libya. Right there, see that? So that's the purpose of scaling it much finer. That's why 5, 10, 15, 20, 25. That's where the scaling comes. If I had a big number like this, if I say 6 and 4, it fell on Spain. Or even if I go 7 and 4, it fell on Turkey. See that? So it's not falling on Libya. So that's why the need for the finer scale in between. Alright? That's how we're going to talk about. Alright? Okay, let's understand that better. Okay, let Mr. Mac remove this, and I'll draw the Cartesian plane, and we'll put some scaling to it. And I'll be back with you in a few seconds. Alright, my dear student, now when you're dealing with Cartesian's plane, you usually draw your y-axis and x-axis and the coordinates in a graph paper like this. Okay, you already have boxes like this, all scaled up nicely. So this way you can put your y-axis and x-axis. Okay, so let's put our y-axis. Okay, let's say very center. We're going to put in the very center right there. That's going to be our y-axis. Okay, so that's going to be y, and then the very center this side we're going to put as our x-axis. Okay, so let's make it thicker so that way we know. Usually in your graph paper the graph will be lighter. Alright, so in this case Mr. Mac kind of draw it on the board with a chalk. It's kind of dark, so I have to make it the axis a bit thicker so that way you know the x-axis and y-axis. So now look at this. Okay, this is going to be your x-axis and that's going to be your y-axis. Okay, so now I can easily put the coordinates. Alright, like see the scales like 1, 2, 3, 4 and 5, and this is going to be your 0. Alright, that's going to be 0, 0, and then of course then I can do the 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5, and then downward is -1, -2, -3, -4, -5. See that? Okay, now this is something we've learned before. Okay, scaling with 1, 2, 3, 4, 5, 6. Now what happens if I want to increase the scale? Alright, so now if I want to increase it, I have to scale it accordingly. Let's see if I wanted to make this on 2, what's going to be next? 4, 6, 8, 10. If I make this one 5, this one's going to be 10, 15. See that? You add the same amount number. Let's say for example, okay, let's say start with 2. I want to start this with 2. If I make this 2, from 0 to 2, so 2 to what? Will be 4. Add a 2 to it. Okay, so this one becomes 4. And then 4, 2, I'm adding another 2 will be what? 6. And then 6 plus 2 will be 8. And then 8 plus 2 will be 10. See that? My scale now changed. 0, 2, 4, 6, 8, 10. I got to do the same thing with the y-axis. Alright? So I do the same thing. This one will be 2. And this one, 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. And then this side, the same thing. Alright? Negative, if I want to start with negative 2. This one becomes negative 4, and this one pretty much the same thing. The scale right here, you just put negative to it. So 2, negative 4, negative 4, 6, negative 6, 8, negative 8, 10, negative 10. See that? And same thing downward. 2, negative 2, 4, negative 4, 6, negative 6, 8, negative 8, 10, negative 10. So now I increase the scale. See that? If the coordinate to fall, let's say right here, right in the center right there. So now I can tell by what? I know this is going to be what? 1. If I put a vertical line, because that's to find the x-axis, alright? What line, where it's touching the x-axis, alright? The line. Okay, it's touching where? Between 0 and 2 will be what? 1. And then this one, y-axis. It's touching y-axis where? Between 4 and 6, which is what? 5. So that means I can tell this coordinate is 1, 5. See that? If I were to have this 0 and 1, this I have to deal with decimal, because we don't want to deal decimal. We want to make it such a way that we have a round number. That's why increasing the scale helps. Alright? So what happens if it falls right here? See that? So then what I want to do? I want to increase this to 0, 4. Or 5. See that? So that way I have more precise. So the purpose of scaling is to make the coordinate, the location of the coordinate, to be exact, to be more precise. So that's why you want to increase the scale. Okay? So now let's say for example, Mr. Mac want to make this into 4. That means I'm going for 0 plus 4 is 4. That means 4 plus 4 is what? 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. See that? And then this side, I just take these numbers, make it to negative. Alright, so negative 4, negative 8, negative 12, negative 16, and negative 20. And then I do the same thing with this one. It will be what? 4, oops, 4, and this one is 8, because 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20. See that? I'm doing that 4, 4, 4 interval in scaling in the form of 4. See that? So I do the same thing this way, because it's going to be negative. So 4 here, this will be negative 4. If it's 8 there, will be negative 8. If it's 12 here, it will be negative 12. If 16 here, it will be negative 16. And 20 here will be negative 20. Alright, pretty easy, isn't it? So it's very important. Now, let's say for example, if the coordinate to fall right here. Okay, if I have a coordinate right there. See that? So now I know that this is 8. So I can find the final in between 8 and 12. So I know this is 9, 10, 11, 12. See that? So now I can say 9, 10, 11, 12. So this means it's 9. And then here 9. Okay, so now I already found their x-axis. Okay, so the line is touching on 9 on x-axis. Okay, that means the coordinate for x will be what? It's 9. Now I want to find the where it's touching on y-axis. So what I have to do, I put a horizontal line. See that? Horizontal line. Okay, so now I'm going to scale it. Okay, this is 8, 9, 10, 11. See that? 8, 9, 10, 11, 12. So that means it's touching on 9 on x-axis. See that? So it's 9, 9. That coordinate is 9, 9. So if I don't have a precise scale, if I were kept with 0, 1, 2, and 3, so now I wouldn't know where exactly that point is. So I have to, then I have to, of course, I have to use a decimal. All right, so it'll be like 0, 1, 2. So it'll be 2 point, 1 or 2.2, something like that. Okay, so that's why increasing, if I want to keep it as a round number, a whole number, I don't want to deal with decimal, then I increase the scale. So that means from 0 to 4 I have a precise scaling. So that's why you increase the scale. Alright, okay, so now Mr. Mac, let's say for example, if I define what would be the point, let's say right here. Okay, let's do that. Let's find that point right there. Okay, so now let's put a vertical line and a horizontal line. Okay, the vertical line will be touching the x-axis. It's touching after the -4. That means, this is -4, -5, -6, -7, -8. So that means it's touching -5 right there on y-axis. Okay, so we know the first coordinate is going to be -5 because we start with x and then y. And what's the next coordinate going to be? The y. And we want to see where it's touching on y-axis. When we put the horizontal line, it's touching right there. If I to scale between -8 and -12, that means this is -9, -10, -11. So that means it's touching at -9. See that? That means that's going to be -9. So that's the purpose of scaling. So you can find it. Alright? Pretty easy, isn't it? Kind of just like Mr. Mac had it earlier. 0, 5, 10, 15. So when the country falls in between, let's say 5 and 10, I can say 7. It points right where the country is. Of course, for the x-axis. And then let's say for a y-axis, let's say it fall between 30 and 35. Then I can say, let's say it fall on 33. See that? Then I can join both lines. One is the vertical and one is horizontal, where the intercept is. That's the country we're looking for. Okay, the same principle. All right? Okay, good. Well, let Mr. Mac erase the board and let's talk more about scaling. And I'll be back within a few seconds. Alright, my dear student, earlier we scaled it which way? We increased it by 4, like 0, 4, 8, 12, 16, 20. See that? That means the scale was what? 1 to 4 for x-axis, alright, and y-axis also 1 to 4. That pretty much we scaled it equally. Alright, now we started with what? 1 to 1. That means 1, 2, 3, 4, 5, 6. We pretty much kept it 1 to 1. Alright, when you change the scale, it's pretty much is 1 to 4. 1 to 4. That means you're scaling same scales. Alright. Can it be different? In other words, can x be, let's say for example, 1 to 4 and y to be 1 to 6? Yes, you can. Doesn't have to be, okay, it's all the time to be same. So in other words, it can 4 to 6 or 3 to 5, doesn't matter which number you choose, based on how easy, how you want to locate the coordinate. That's the thing. You customize your Cartesian's plane in such a way that whatever you're locating the points, it falls. All right, exactly. So you got x. Okay, now look at x to 1 to 4 scale and y to 1 to 6 scale. All right, see that? So it doesn't have to be, so it has to be all the time to be same. Okay, so these two are same. And okay, so in this case you scale x-axis 1 to 4 and y-axis 1 to 6. It's a difference there. See that? Alright, they are different. Like this one is same. You scaled it for the same. This one different. Alright, so different. So you can see that. So we scale the x-axis and y-axis, in this case same. We scale the x-axis and y-axis different. Okay, let's do the different. Earlier we did the same. Alright, so let's scale x 1 to 4. So first what do? We draw the axis. Okay, let's do start with x-axis right there, x-axis right in the center. Let's make it, darken it better. And then y-axis is the vertical line. All right, this is the horizontal line and this is the vertical line. All right, once we've done that, okay, let's make it thicker so that way you can see better. Okay, there we go. And then put an arrow. All right, okay, good. Now we want to scale this to 1 to 4. That means what? Locate the 0, the origin right there, the 0. That means you're increasing by 4, 4, 4. That means 4, 8, 12, 16. Now also on the other side, follow this. That means -4, -8, -12, -16. See that? The mirror of that, but it's a negative because you're going to the left of the 0. When you go to the right, it's positive, left is negative. Alright, now what about y? Always look at this, what they're asking you to do. They want scale 1 to 6. That means 0, 6. There you go, 0, 6. And add a 6 to it, 12. Add a 6 to it, 18. Add a 6 to it, 24. Add a 6 to it, 30. See that? Then you just mirror it. 6, and this will be -6, -12, -18, -24, -30. See that? Pretty easy, isn't it? How to scale them? Okay, so now Mr. Mac wants you to locate points, the coordinates, alright? Okay, let's say I give you the point A. So I said you want to find A, let's say you want to do 8, 24. And then I want to do, you find B, let's say -4, -30. Okay, then I want you to find C, let's say -8, -12. No, actually, let's do +12, alright? Okay, and then I want you to locate D, let's say D, I want you to locate, let's say 12, -18. Let's put all these points. Alright, let's start with A. So we know this is going to be X and this is going to be Y. So A is 8 and 24. That means right 8 up by 24. Okay, so right there, that's going to be your A. See, 24 and 8. See that? 8 and then 24. That's your A. Let's look B. B is -4, and you know that's your X and this is your Y. -4 and -30 is right here. See that? -30 is right there. Okay, that's going to be your B. And then let's look for C. C is what? -8. -8 because C will start with X and then Y. -8 and then Y is 12. Okay, so -8 and 12 right there. See that? So that's your C. Okay, so now let's do D. So D is 12, -18. So 12, -18 right there. See that? -18 is right there and 12 is right there. Okay, see, that's the nice about have a graph paper because it pretty much drawn the line for you where the intercept is right there. When there's no graph, you got to put the vertical line and horizontal line. Alright, okay, so see that? This is the vertical line and the horizontal line, intercept right there. And that's going to be your D. See, that's been scaled differently. This one by 4 and this one by 6. So you can do that. Doesn't have to be all the time same. Doesn't have to be all the way down 1, 2, 3, 4 and forward and so forth. Okay, you can have 2, 4, 6, 8, 10 or 4, 8, you know, and you can have different for x-axis. And this one can be more, this one can be less. In other words, this one can be 10, 20, 30, 40, and this one 6, 12, 18, 24, 30. See that? Alright? Okay, good. So now let's say Mr. Mac to give you points on the graph, alright? On the Cartesian plane. Alright, let's say for example, I say find the coordinate for this point right here. Let's say this is R, and then let's find another one like this is S, and then let's say this is T, and then let's find another one, let's say this one right here. Okay, right here, this one is going to be U. Alright, okay, let's do that. Let's find R first. Okay, R is right there. To find this coordinate, first let's do this. Okay, let's put R, put a bracket, and then put a comma in the middle. And we know this is going to be your X coordinate and this is going to be Y coordinate. Alright, okay, so let's start with X. So that means where it's touching on the Y axis. Okay, for R it's touching on 4, so that's 4. And what about Y? It's touching on the 18, so it's 18. So 4, 18. So very important to able to find the coordinate even though the scales are not equal, they're different scale. Alright, but doesn't matter, you can still locate them. Alright, let's say for example you want to find our S now. S is right here. Okay, do same thing. You put an S, put a bracket, put a comma in the middle. You want to find x first and then y. So what is x? X means you want to find the line is touching the x-axis. Okay, so you want to go straight up, it's touching it, -4. So that means the x is -4. Y, look for the one is touching on the y-axis, -18. See that? Now let's look for t. Okay, so let's put t again, comma, and then x and y. We want to start with x first. Okay, so t is on, where is it? This is the x-axis, right on top of the x-axis. All right, that means 12, and it's right on top of the x-axis. That means y is 0 right there. That means y is 0. All right, so keep in mind, if a point on top of the x-axis, the y is 0. The point is on top of the y-axis, then x equals to 0. Okay, so let me repeat again. Okay, so when a point falls anywhere along x-axis, all right, anywhere along x-axis, y will become 0. Y will be 0. All right, no matter where it falls, anywhere along the x-axis, okay, y will always be 0. Now if the point is fall along the y-axis, then x will always be 0. No matter where on the y-axis it falls, x is 0. All right, because look at that, along this, x is what? 0, because 0, 4, 8, 12, see that? So when it's right there, this is all 0, represents 0 for x. This one represents 0 for y. See, that's 0, -6, -12, 0, 6, 12. So along this line is what? It's 0. Along this line, y is what? 6. Anywhere along this line, okay, y will be what? 6. Along this line, 12. Along this line, 18. Along this line, 24. Along this line, 30. See that? So same thing with x-axis. Along this line is what? 0. Along this line will be anywhere 4. If I pick this point, x will be what? 4. If I pick that point, x will be what? 4. See that? Now with this line also same, 8. All right, 8 right here, 8 right here, 8 right here, 8 right here. See that? Because along this line, x is 8, x is 12, x is 16, x is -8, x is -12, -16. See that? So keep in mind. So again, if the point falls on x-axis, y is 0. If a point falls on y-axis, x is equals to 0. All right, good. All right, so you know how to locate, all right, okay, and also how to find the coordinate and also locate the point on the Cartesian plane. All right, so you know vice versa. Okay, good. Now let's say, for example, if Mr. Mac to tell you, I have, let Mr. Mac erase the board. Give me a few seconds and I'll be back. Alright, my dear student, this time we want to learn how to locate a coordinate of a figure. Alright, let's say for example, Mr. Max gave you A, B, C, the missing point is D. Okay, I want you to find what is D such a way that will make a square. We want to find the vertex of D that makes it into a square. Alright, what do we do? First, let's locate A, B, C first. Alright, let's put them. Okay, A, -4, 18, which means x, y. Okay, we're going to start with x, which is -4. That means you're going to the left. -4 right there, and 18 is right there. So that means that's the point A. Okay, so we found point A. Now point B is 12, 18. Again, x, y. So 12 is going on the right hand side. So 4, 8, 12. And then 18 is up. So that means right there. All right, so that's your B. And C is 12, -6. 12, -6 is right there. See that? So now let's connect the points. So A to B, B to C. Now it says that this one forms a what? A square. Now what do we know about square? All side length are equal. Okay, that means what? 1, 2, 3, 4 units. 1, 2, 3, 4 units. In order to make a square, you have to go 4 units to the left and 4 units to the up. See that? So that forms a square. So that means 1, 2, 3, 4 right there. And then 1, 2, 3, 4. So that makes a square. So we want this point right there, D. So we found the point D. So we want to now find the coordinate for D. Okay, so that means we're going to put a comma and then we want to find X and Y. We're going to start with X. Where is it touching on X axis? Negative 4. See that? Okay, negative 4. So it's going to be negative 4. And what about Y axis? Negative 6. See, negative 6. So negative 4, negative 6. That makes it into a square. So if I to darken that line, look at that. A perfect square. Okay, so let's say if I give you another one. Okay, let's say this time I give you, let's say I say R, point R is, let's say, all right, negative 12, 12. Okay, I say negative 12, 12. S is, let's say, negative 12, negative 6. All right, and then I gave you, let's see, 8. T is 8, let's say 8, negative 6. Okay, so negative 6 right there. All right, so I told you that I give you points R, S and T, and I told you that forms a rectangle, and I want you to find the vertex for U. Find what is the vertex for U such a way that when I combine, we connect these points, will form a rectangle. All right, so what's our first step? Locate the coordinates. All right, let's start with R. R, so X and Y. So X is negative 12. So let's find negative 12. 0, negative 12 is right there. And then Y is 12. So Y is 12 right there. So that's your R right there. All right, we found R. And then now we want to find S. So is it has to be in order? Yes, because we want to connect in order. R, S, T, U. Very important. That's why you cannot go like R connecting to U, U connecting to T, and a T connecting to S. You cannot do that. R, S, T, U. All right. So that makes it in order. All right. So now we found R. Now let's find S. S is negative 12. So that means X is negative 12. Y is negative 6. Again, negative 12 is right there, and negative 6 is right there. So right there, that's another point, which is the S point. All right, and then you're given T is 8, negative 6. That's X and that's Y. 8 is which way? To the right. 4, 8. And then Y is negative 6 right there. Okay, so it's going to be right here, negative 6. Okay, so now let's combine them. Let's connect the points. Right there. See that? So now, in order to form a rectangle, you need to have a line like this and this. This is what it's supposed to. It's supposed to meet right there. See that? So you want to go straight out like this, straight out like that. That's the point. The next point in order to form a rectangle. So that's going to be your U. So what's your U? Your X is what? So in other words, for U, we want to find the X first and then Y. So X. From X axis, you come down, you're touching 8. Y axis is touching 12. See that? And that's your U. Now it forms what? A rectangle. Does that make sense? So this is something that you learned about the shape, and you're applying it now on a coordinate system. See that? Everything that you learned previous comes handy. See that? It's all built on top of each other. That's what about mathematics is all about. Okay, good. I'm glad you understand how to locate the coordinates and how to find the coordinates. All right? All right? And also able to form a figure, shapes. If I had to give you only 3 and then the missing vertex, you should be able to find them, locate them. Okay, good. That should prepare you for hands-on practice. Let's see what Pablo's doing. look like he's done. He's been waiting for us. Did you see that? He's shaking his leg. He's ready. All right, let's not call him yet. Let Mr. Mac erase the board, get ready, and then we'll call him out. Okay, let him take a break, all right? He's way ahead of us, isn't he? He's trying to tell us, well, I'm done. I'm waiting for you, waiting for you and my students. You know, that's what he's trying to tell us. All right, my dear student, give me a few seconds. I'll be back. Alright, my dear students, are you ready for some hands-on practice? I know you are. Well, let's call Pablo, alright? Pablo, come on over, Pablo, come on over. Bring the worksheet with you. Here is Pablo. Well, my dear students, once Pablo hands over the worksheet to you, be sure to pause the video and then have fun. All right, now be sure to have a graph paper. All right, so that will help you a lot to draw the x-axis and y-axis and able to put the points and things like that. All right, good, and have fun with it, and then be sure to pause the video and then invite Mr. Mac in after you're done. I'll be here waiting for you. Oh, good. Well, let's do it. All right, ready? Okay, the first problem says mark the values in each graph below based on the scale given. All right, so you're given a graph. Okay, this one, Mr. Mac's not going to draw all the boxes because we're just doing the scaling. For the second problem, yes, we'll do the boxes, okay? But in your case, if you have a graph paper, it will help. If you didn't, if you can draw the x-axis and y-axis, okay? So let's do that. So let's do the y-axis and then x-axis, and then, so there's x and that's y, and then you're given, okay, this is 1a. And the scale is given as x-axis is 1 to 2 and y-axis is given 1 to 6, and then I gave you 1 2 3 4 5, and then 1 2 3 4 1 2 3 4 1 2 3 4 5. So I want you to scale that. All right, so 1 to 2, that means 1, that means this is 1 1 1 1. Each scale, which is 1, represent 2. That's what it means. That means this is 2 4 6 8 10. I'm adding 2. See, there are 2. I'm adding 2 to each numbers. All right, like 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10. Now to go to the left hand side, which is all the negative numbers, just mirror this, except you just put the negative, like the negative 2, negative 4, negative 6, negative 8, negative 10. All right, same thing with this one, because you know this is 0. So 0, what this will becomes? Wait a minute, we got to see what they want for the y-axis. All right, Mr. Mac just jumping ahead. I shouldn't. Now they want y-axis to be what? 1 to 6. That means each scale represents 6. That means 6. We're going to start with 6. And what is this going to be? 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. Alright, and then we're going to mirror this into negative. Alright, so this will becomes negative 6. Okay, actually I should write there, but this one's on the way. Maybe Mr. Mac put that smaller. Alright, this is negative 6, negative 12, negative 18, and negative 24. See that? That's it right there. You scaled it. Alright, based on the scale that I gave you, 1 to 2 and 1 to 6. Okay, let's do problem B. Now problem B, again, let's put y-axis, x-axis. So this is y and this is x. All right, and then let's scale them. All right, so we're given 1, 2, 3, 4, 5, 6. So that means 1, 2, 3, 4, 5, 6. And then this way is 1, 2, 3. 1, 2, 3. 1, 2, 3. And the scale I gave you is for x-axis is 2 to 1. And then y-axis is 1 to 4. So you wonder, what is that 2 to 1 stands for? Like this one, 1, that each scale is 1, I put 2 to it. This one, the 2 scales, I put 1 to it. That means 1, 2 right there. This one is 1. 1, 2, this one's 2. 1, 2, this one's 3. See that? That's what that means. Alright? That means I mirror it now. See that 1 becomes negative 1. 1, 2, negative 1. 1, 2, negative 2. 1, 2, negative 3. Alright? Now look at this. This one, 1 to 4. That means each scale you just put 4. 4, 8, 12. Mirror it. Negative 4, negative 8, negative 12. See that? Very important, this. That means 1, 2. 2 represent 1. 2 scale represent 2 because scale is 1 plus 1 plus 1. You're just adding 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. See that? But you're moving, giving 2 scales in between. Alright, from 0 to 1. 1 to 2, you're giving 2 scales. Alright? Okay, let's do C. Okay, C, we're given, so we do y-axis and x-axis. Alright, it's convenient to put a straight line and then a vertical line and then horizontal line. That's why Mr. Mac always start with the y-axis and x-axis. That nothing to do with, okay, don't that confuse you between when you have a bracket, x comes first, y comes next. Alright, this is just to draw. Mr. Mac, easier for me to start with y-axis and x-axis. The scale that was given to you is this x-axis 2 to 3 and y-axis 2 to 5. So 2 to 3 and 2 to 5. Alright, so let's put the scale. Alright, how many is given? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. And then I gave you 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright? Okay, now I'm going to scale them. Okay, let's start with x-axis. That means 2 scale represent 3. That means 1, 2 right there. So I'm going to put 3 right there. And then 1, 2. 3 plus 3 is 6. Nope, 6. Okay, and then 1, 2. So it'll be what? 6 plus 3 is 9. 1, 2. 9 plus 3 is 12. See that? That's what that means. Every 2 scales, the number goes from 3, 6, 9, 12. Increment of 3. Alright? Because 0, this is 0. 0 plus 3 is 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. Alright? Now, let's look at y-axis. Y-axis is what? 2 to 5. That every 2 scales represent 5. That means 1, 2 right there. That means that's 5. 1, 2, 10. 1, 2, 15. See that? Okay, because we're incrementing by how many? How much? 5. 5 plus 0 plus 5 is 5. 5 plus 5 is 10. 10 plus 5 is 15. I'm going to mirror it down. Alright, let's mirror this one first from x-axis. That means 1, 2 right here is going to be negative 3. 1, 2 is going to be negative 6. 1, 2 is going to be negative 9. 1, 2 is going to be negative 12. Mirror it down, except we're going to make it negative. 1, 2. 1, 2 is going to be negative 5. 1, 2 is going to be negative 10. 1, 2 is going to be negative 15. See that? So very important to understand. This is representing the scale. This representing the number. Alright? The increment of the number. 3, 6, 9, 12. See that? I'm moving by 2. Alright? You got it? Good job. Proud of you. Okay, good. Well, let Mr. Mac erase the board and we'll do problem number 2. And I'll be back with you in a few seconds. Alright, my dear student, ready for problem number 2? Let's do it, okay? Now, the problem number 2 said 3 of 4 vertices, okay, of a square are A, negative 3, 2, B, negative 3, negative 1, and then C, 0, negative 1. Find the coordinates of the 4th vertex, okay? So let's write that down, okay? So you're given 3 vertices, alright, out of the 4 of a square, and we know what's the characteristic of a square. all sides are equal length. See that? Okay, so now we're doing problem number 2. Okay, so the given point, okay, the points are A, the coordinates are A is -3, 2, and B is -3, -1, and C is 0, 1. And we want to find the fourth one, so which means we're going to find the D, which we don't know what D is, so we're going to find it. First, let's locate them. Let's plot those A, B, C coordinates into the graph. Okay, so I already got the graph, the Cartesian plane drawn, and let's scale them. All right, so okay, so let's write down. Okay, problem number 2. Okay, the coordinates are given. For A is what? -3, 2, and B is -3, -1. C is 0, -1. And we're looking for the fourth vertex, okay, which would be D, and which we don't know, but we know it's going to be X and Y. All right, so we're going to find it. Let's plot A, B, C first into the Cartesian plane. All right, that's going to help us to find the D. That's going to make it easier. Okay, let's start with A. A is -3, 2. So that means we know this is X and this is Y, and we know X coordinate is what? -3. So let's find X. -3, that means going to the left negative by 3 times. 1, 2, 3, right there. Alright, we're going to start right there, and then we're going to go up by 2, +2. See that? Up by 2, 1, 2. That's the A. Okay, that's going to be our A. Now B is going to be -3, -1. Again, we're going to the left by 3, 1 by down by 1. Alright, so 1, 2, 3, down by 1, right there. And that's going to be your B. And then C is 0. X is 0. X is 0. So where's the axis? X-axis is right there, and it's 0 right there. And down by 1 for Y. Down by 1. Right there. That's going to be your C. Now let's join all those lines. So that gives us the semi shape. Okay, right there. 1, 2, 3. 1, 2, 3. See that? That means I have to find 1, 2, 3. Go up. 1, 2, 3 to come this way to the right. See that? And this is the next vertex that we're looking for D. That's going to be D. See that? It forms a square. Alright? So what is that point? X is 0, Y is 2. X is 0, Y is 2. See that? X-axis 0. And Y is 1, 2. Alright? So that's the point for D. Pretty easy, isn't it? Alright, let's do problem number 3. Problem number 3 is 3 or 4 vertices of a rectangle. So what's the characteristic of a rectangle? Exactly. Rectangle has the opposite length are same. Alright? Opposite length are identical. That's rectangle. And this is for square. Alright? All sides are equal. And then opposite sides are equal for rectangle. Alright? So let's plot them. Okay, we're given the points for R is what? -1, 3, and then S is 3, 3, and T is 3, -2. So R, S, T, U. U is the one we're finding. Alright? So we don't know what's U, which is going to start with X and Y. So let's plot these points first into the Cartesian plane, and then we should able to, because we know they're looking for a rectangle shape, so we should be able to draw that. Alright, let's do that. Let's start with R. R is -1 and 3. X is -1. So let's find what -1 is for X. Right there. Alright, and 3. +3. That means going up by 3 times. 1, 2, 3. See that? See, -1 is right there. See 0, 1, -1. 1, 2, 3. That's our R point. Now let's look at S point. 3, 3. That means I'm going right 3, up 3. 1, 2, 3. Always 0 is your reference point. Okay, always start with the origin. 3 to the right, 3 to the up. That's a positive. Okay, 3 to the right, 3 to the up. 1, 2, 3 right there. That's going to be my S. And T is 3 to the right, 2 to the down. See the negative? Alright, 3 to the right, 1, 2, 3, 2 to the down right there. That's going to be my S. Now, I'm sorry, that's going to be my T. Alright, we already found the S. This is going to be T. Now let's combine them. We got a semi-rectangle yet. Alright, okay, we're going to get semi-rectangle. Okay, see that? So you know that in order to form a rectangle, this comes straight down and this go that way. Right there, it's intercept right there. That means Right there, the rectangle should be right here. That's going to be the next vertex right there. RST, and this is going to be your U. So what's U? Alright, let's start with X. X is what? -1. Y is -2. See that? -1, -2. That's going to be a U. See that? U. Always x-axis. See where it's touching at x-axis? -1. Where it's touching at y-axis? -2. -1, -2. You got it? Good job. Proud of you. Right there. See that rectangle, all right? Because you can tell 1, 2, 3, 4 units, 1, 2, 3, 4, 5 units. That makes it because 5, 5. See that? Opposite are same length. 4, 4. Opposite are same length. All right? That's it. Good job. There's Pablo. All right, Pablo. Thank you. It's time for quiz. And you did awesome on your hands-on practice. All right, my dear students, have fun with your quiz, all right? And then come back, see Mr. Mac on the next sub lesson. It's going to be a fun one. I'll be waiting for you. Okay, have fun. Bye-bye.